This is an Algebra 1 class, and today we're going to look at quadratic functions, finding the line of symmetry and the vertex, and telling whether the vertex is a maximum point or a minimum point of the graph. To start with, the standard form of the equation for a quadratic function is y equals ax squared plus bx plus c. The line of symmetry is going to be found when we take x equals the negative of b divided by 2a. Now, when b is equal to 0, this line is going to just be x equal to 0. But we're going to be looking at ones today where the b is not equal to 0. And then once I find what the line of symmetry is, the vertex is going to be on that line of symmetry. The vertex is going to have that x coordinate of negative b over 2a, and the y coordinate we're just going to substitute into the equation. So let's see how that works. Let's start by identifying a, b, and c in our first example. So we have y equals negative 2x squared plus 12x minus 7. So we have our a, our b, and our c. Our a is negative 2, our b is 12, and our c is negative 7. So our line of symmetry is going to be x equals the negative of b, which is 12, divided by 2a, so 2 times negative 2. Or as we look at our values here, it's the negative of 12 over negative 4. Well, that ends up being positive 3. So this is our line of symmetry. The vertex is going to be on that line of symmetry. So I'm going to use 3 for x, and I'm going to find my y coordinate when x is 3. So to find the vertex, the y coordinate, I'm going to use x equals 3. So y equals negative 2 times 3 squared plus 12 times 3 minus 7. Simplifying, we have 3 squared is 9 times negative 2 is negative 18 plus 36 minus 7. So we end up with 18 minus 7, or 11. So our vertex is going to have coordinates 3, 11. Okay, now we also want to know if this vertex represents a maximum or a minimum value of the graph of this function. When we looked at basic graphs of parabolas, such as y equals x squared and y equals negative x squared, a graph with a negative leading coefficient is one that faces downward. So this equation, y equals negative 2x squared plus 12x minus 7, has a negative leading coefficient. Since the leading coefficient is negative, this graph will face downward, and the vertex will be a maximum. Okay, let's look at another example. In this case, we have y equals ax squared minus 2x plus 3, which in standard form, we have our a, b, and our c. Our a is our leading coefficient, which is 1. B is negative 2, and c is 3. So for my line of symmetry, we're going to have x equals the negative of b divided by 2a. So negative 2 divided by 2 times 1. Since I have a negative of a negative, that becomes positive. So I end up with 2 over 2, or 1. So our line of symmetry is x equals 1. Now to find the y coordinate of the vertex, I'm going to use x equals 1 in our equation. So y equals 1 squared minus 2 times 1 plus 3. So y is going to equal 1 minus 2 plus 3, which is 2. So our vertex is the ordered pair 1, 2. Now, to tell whether or not this vertex is our maximum or minimum, I look at my leading coefficient. The leading coefficient is positive, it's 1. So the graph of this parabola would be facing upward, and our vertex is going to be a minimum. Okay. Let's look at an application of this. It says the suspension cables between the two towers of the Mackinac Bridge, I think that was in Michigan, form a parabola that can be modeled by the graph of y equals 0.00097x squared minus 0.37x plus 549. X is our horizontal distance in feet from one end of the suspended cable, and y is how high the height is. So if we start at this end, that would be x equals 0, and we move along the bridge till I get to the x value where the cable is suspended on the other tower. And the height is how high the cable is from the water. Our question is, what is the height of the cable above the water at its lowest point? Well, the lowest point is right here, so the lowest point is going to be the vertex of the parabola. So that means I need to find the vertex, and to do that, step 1 is to find the line of symmetry. So let's find the line of symmetry. We need to identify our A and our B. Our A is our coefficient, leading coefficient, the coefficient of x squared. So it's 0.000097. And our B is our coefficient of x. It's negative 0.37. So our line of symmetry then is going to be x equals the negative of B over 2 times A. Okay, 2 negatives, we end up with a positive there. Let's use our calculator to find that value. Then take 0.37 divided by the whole denominator. So in parentheses, I'm going to do 2 times 0.00097. And my line of symmetry is going to be x equals 1907.2. So as I move from one end of the bridge towards the other end, I'm going to go 1,907.2 feet. And now to find the lowest point, I need to find the vertex. So I need to find the y-coordinate. So the vertex y-coordinate, I'm going to use this value for x in our equation. So y equals 0.00097 times 1907.2 squared minus 0.37 times 1907.2 plus 549. Again, I'm going to use a calculator to calculate that. So let's set that here where we can see the two. I'm going to do 0.1234097 times 1907.2 squared minus 0.37 times 1907.2 plus 549. And I get a y value of 196.2. We're going to round that to 196 feet from the water. Okay, and that's our lesson on quadratic equations, finding the line of symmetry, the vertex, and identifying whether the vertex is a maximum or a minimum.